All right, good morning, everyone. I will continue to say good morning until 6 p.m. today. This is a talk about an open source universal router, not only for power line communications, but for also for USB and for other devices that can be connected to the network. And let me introduce Florian, who is a student of telecommunications engineering, I think. Yes. And Xavier is the chief technical officer of Open Pattern, which is a French company. So there's a warm welcome for you. Let's have an applause for the people here.
Thank you. Thank you. Everybody can hear me? Yeah. So first, it's a great pleasure to be here and be able to speak out in front of this crowd, as it was, I was on your side in the previous CCC, so it's a great pleasure to present something. So we have 45 minutes to discuss one tool that we've been developing since a year about what we call PLC, which stands for Power Line Communications. The idea behind power line communications is to use the electrical cables to set up logical network. And so far there was no real open source tool that can be used to configure or to try to do extensive features like we will see. So why faifa is a long story. I will make it short. Faifa means electricity in Lao language. Laos is a small country of 4 million people located between Vietnam and China and Thailand and Cambodia. And basically in Lao languages, you don't have very modern terms. So when you want to make a technical term, you have to add words together. So for electricity, you have to add fire and light. So the logo of the tool is basically faifa written in Lao language. So the outline of the presentation, first I will do a small 101 class of what is power line communications for those who are not familiar with this technology. It's basically located at the physical and MAC layer. We will see a little bit of security issues, and then we will target one specific standard, which is called HomePlug AV, which is the latest power line communication standard, industrial standard. As we speak, last week, there is an IEEE group which works on the standardization of this technology, and they have been voting different baseline for the future draft of the standards. And on last Thursday, they've been voting for this HomePlug AV technology to be the baseline for the next generation of standard for IEEE. So the name of the standard will be IEEE 1901. And because they are using HomePlug AV for the draft, we are pretty confident that the tool we have been developing for HomePlug AV will be able to be ported and used for the next IEEE standard coming in 2009. Then we will go more in details about the hardware parts and what are the features of the faifa tool. And a little bit of a demo with some equipment that we brought that you can find out there in the market. So, like I said, power line communications is the usage of electrical cables for logical area network. Could be on the public electrical network, could be on the private electrical network. Basically, you can split applications in two main groups, outdoor and indoor. In the outdoor applications world, the idea is to provide internet access over electrical cables from the core electrical network to the very end user after the meter, electrical meter that you have at home. And you have the so-called private electrical network, the one that you can find after the meter, after the electrical meter, and that covers the electrical network for a home or a building, hotel, hospital, and so on. If we make an equivalent between what we have in networking, you can imagine the electrical cable environment like a big hub at the layer 2, and basically you will have the plug on one side and the RJ45 on the other side. If you plug that all over the electrical network, you will have basically a big hub where the media is splitted and shared between all the tools and devices connected on the electrical network. Just a little bit of history. Like I started my talk, now IEEE is doing a standardization of this technology. So far, there were no real IEEE standards, so there were a fight in the markets between different technology. In light, you have what we call high bitrate technology. This technology are using the 1 to 30 megahertz frequency band, this part. And in light gray, you have some low bitrate power line. I'm sorry for the quality of the schematic. And the low bitrate is using this band, which is the 3 to 150 kilohertz, which holds less space for bandwidth and bitrates. So we will target high bitrates. That's the one used for logical IR network. And like I said, the standard coming up is called IEEE 1901. Basically, IEEE is going from 1 to 802, and then they continue with different technology. And for power line, it's the 1901 group. So the standard will be called 1901. I'm lacking one schematic, I don't know why. Basically, the idea was to show you the two main applications that I was talking about, outdoor and indoor. So indoor, basically, you have the green signal going from electrical plug to electrical plug. One question that we have often is, do I have the signal going outside of my house or my electrical network? Basically, it depends on the meter, but for most countries, the meter is not blocking the signal. So you will find the PLC signal from your neighbor or from next door going to your electrical network, and there is no real blocking of the frequency that I was talking about. So if I go a little bit more in details about the physical and the MAC layer, at the physical layer, they are using OFDM, orthogonal frequency division multiplexing. That's the one technology that we can find in most network technology like DSL, Wi-Fi 802.11g, WiMAX, and so on. And there is an adaptive coding depending on the quality of the channel. So they will switch from the best quality of modulation and coding with 1024 QAM, which is quite high, low to PSK for more robust transmission. If you do the math at 1024 QAM, you can go up to 200 megabits per second at the physical layer. At the MAC layer, you will find CA-CA, so you will find a medium which is not able to give you collision detection, so you will have to implement collision avoidance, and the rest will be crazy similar to 802.3 IEEE frames. So basically what is doing OFDM is splitting the binary stream between different sendbands and transmitting the sendbands from one part of the electrical network to the other part. If you have perturbation between these bands, they will not block the whole bands because OFDM is very strong to be only perturbated by one subbands. More visually, we've been doing tried of sniffing PLC communications. So as you can imagine, the cable is behaving like an antenna. Especially electrical cable are basically straight going in each rooms, each part of buildings. So you will have some emissions, radio emissions outside of the cable. If you make a test at 1 meter with a signal analyzer and you try to use 60 kHz per division, you will find in the 1 to 30 megahertz DOFDM modulation. So this is 1, this is 30 megahertz. You will see basically the physical layer, and you will have the adaptive modulation changing all the time when the channel is changing, basically when some electrical plugs, electrical devices are changing the quality of the channel. So this is what we find at the physical layer using a signal analyzer. Now in real, in the market you can find many types of PLC equipment. You will find Ethernet bridges for PLC line, basically that kind of tool where you have like the electrical plug, could be European or Japanese or American, and you can find the Ethernet ports. On the same idea, you will find different devices like set-top boxes. For instance, in France, we are very fond of set-top boxes for DSL access. So now all the ISP in France are using PLC for local area network between devices of the offer they have. You will see MCU gateways, some equipment that you can put at the head of the electrical network for a building, and from that you can spread the signal over the building. In the US you will find something called sling boxes, where you can take the video cast stream and resend that stream over either a local network or a remote network. Some IP video cameras are using PLC now. A device called Y-Power, basically it's like an electrical charger, except that he has two cables, the electrical cable going to feed the devices and the network cable going to the boxes. And you have some ISP devices also. I think the main change will be that IEEE now, by choosing one technology, will make more confidence into the chip market, and the people in the chip market will develop chips that they will embed in some devices. I am pretty confident that in some year we will have, like we have Wi-Fi chips inside laptops, we will have PLC chips inside laptops. And you will be able just to plug your laptop and get the feed from the electrical network from power line signal. So like I said, we are basically stacking the classical physical and MAC layer. So you will find the physical data units embedding the MAC layer data units and then transmitting that over the cable. So if we look at the security issues in power line communications, the first one, compared to Wi-Fi, is the difficult access to the medium. Wi-Fi is radio, so anyone is able to basically sniff the radio, either in promiscuous mode or active mode. In the power line communications, if you want to sniff, you need a complete set of tools to have from the logic analyzer to the analog to digital converter, demodulator, then you need to dump the data and you need to decrypt that data. So it's not easy like you can find a chip card and just dump the data and do the decrypting offline. Plus, at the physical layer, like I said, every 5 seconds you have reconfiguration of the modulation. So if you are sniffing, if you want to sniff the whole packets, you will have to be able to change the modulation picked by the devices every 5 seconds to be able to reconstruct the bit stream. In terms of in terms of keys used. Before Unplug AV, there were another technology called Unplug 1.0, which were able to do 14 megabits at the physical layer. And this technology is using what we call NEC, Network Encryption Key, is the WEP or WPA key for PLC. This is a key at layer 2, and they were using 56 DES encryption. The next generation Unplug AV that we are looking at is using AES 128 encryption, and the network architecture is basically in two parts, coordinator and stations. It's not really a master-slave architecture, but similar to that, where the coordinator is managing the whole network and will give access and will give credence to every station connecting to the network. One other important key issue is that if you don't have the right network function key, you will not be able to get the Ethernet frame on the ARG45 side. Meaning that if the device is not configured with the right key, the only part of the device that can access the frames is the electrical part. So you have a kind of protection from the chip side to prevent frames going on the Ethernet cable. Finally, in the same idea, the major chip vendor now is called Intelon, American-based, and they have two major chips, 5500 and 6000. And this chip is embedding this functionality of the network encryption key that makes the separation between electrical cable and Ethernet cable. Though there is a small hole in the security that they wanted, because they wanted to implement what they called an easy mode, easy connect. They're not supposing that everybody can implement and configure every devices. So on the devices, you have a small button, and if you press that button, you have a 1 minute time frame to press the button of the other devices that you want to pair, that you want to be part of the same network. In this 1 minute time frame, they will use what we call a TEK, temporary encryption key, and they will be able to exchange the actual network encryption key using that TEK. So you have to be there when they do that 1 minute time frame, but during that time frame, there is some frames using a temporary encryption key and some very first frame transmitted in clear. Again, you need to be able to sniff the medium to be able to get these frames. So, if we switch on the Unplug AV and we make a focus on that, Unplug AV, like I said, allows in the 1 to 30 megahertz band, 200 megabits at the physical layer. This is in the base case. Everything is nice, the electrical network is clean, so the channel estimation is at the best, and you can estimate that you will have the most bandwidth. Of course, electrical networks are subject to interferences from different devices that you have unplugged on the electrical network that will change the whole impedance and the whole characteristics of the network. So you will switch probably from 200 megabits to 100 or 50 megabits if you are going to a robust mode. The whole managing configuration aspect of power line communications is done by 802.3 frames, and these frames can be recognized on a network because they are using a specific FA type, which is 88E1. So if you see any frames like this with your favorite Wireshark or TCP dump, this is power line communications frames for Unplug AV. We can think that IEEE may use the same FA type. If you are implementing a Unplug AV, you can have up to 256 devices on a logical power line network, but you can also divide your electrical network into different logical networks. And of course, you will share the medium, but you will be able to make a different logical power line communication network. The architecture, like I said, is one coordinator. There is an automatic election of the coordinator. When you plug your devices, one device will be elected by the other because it's well located on the electrical network, so it can interact with all the devices, and the other one will be in station mode. So you can refer to a kind of master-slave architecture. With faifa, we wanted to be able to interact with the different devices and being able to monitor in real time the physical layer coding modulation scan, so we can understand what is being used at the physical layer and how from the theoretical 200 megabits in real life which modulation are used. Last feature, Unplug AV described the technology where they can use CSMA-CA or TDMA. TDMA is time division multiple access, and they are able to use that because on the electrical network they have a natural carrier which is the 50 or 60 hertz. So by using the zero crossing time, they are able to do a time synchronization of all the devices, so they can be able to do a time division of the time and say the station can send or receive, and they can have a quite good quality of service on that one. In real life, most of the devices are using CSMA-CA because they have been used, they have seen some feedbacks that TDDMA is using lots of processing on the embedded devices. Again, in real life, ISP, Internet Service Provider, are pushing power line communication now. All the major ISP in France, in Germany also, are proposing what they call either net plug or free plug or live plug, which are power line communications devices to connect the different boxes that they have in home. And for instance, NEF, one of the major ISP, is proposing these boxes to connect the DSL modem to the video decoder or to the third laptop or third computer that you may have or printer that you may have at home.
Okay, so thank you, Xavier. I'll give you a short focus on what kind of hardware there's inside the PLC bridges or system-on-chip architecture. So it's there's basically an analog front end to encode the analog signal and decode it. Then you get a high-speed analog converter, and most of the time there's a chip which is equivalent to the Ethernet PHY chip, which is a INT 1000 series chip for the Intel-based devices, and which is MII connected to PLC Mac, which is implemented either by Intel 5500 or Intel 6000 based device. But any other PLC vendor uses the same architecture. Inside the chip, which acts as a Mac, there's a firmware inside, which most of the time has been, which is ARM architecture, so there's ARM code inside. And so the chip is using a real-time operating system, which is Nucleus. And so it's doing all the Mac operations, and you can query the chip using special Ethernet frames. Some are documented and are standard, and some of them are proprietary. So you can encode your request on 2 bytes. So you have quite a lot of possibility to implement proprietary queries. And on the other side, you get, of course, an Ethernet PHY and possibly an Ethernet switch, depending on the architecture you want to have. So, as Xavier presented you, Ethernet powerline configuration frames appear with a specific error type, which is 88E1. So faifa, I'm not sure we've been able to upload it yet because we took the train this morning and it was a bit difficult. You may notice if you have devices at home that same devices using different firmwares act differently, and things that may be standard in fact are not. So if you can test the tool at home with your devices, that would be great to show, to make a compatibility matrix, for instance. We've been talking about that already. There are in fact some tools to configure devices. This one was done by, not sure it's developed, Intel. So you can see the devices on the Unplug AV logical network and eventually the quality. I'm not sure the computation of the quality was right, but you can see a kind of network topology of your logical network. There was a tool which we used originally, which is a tool developed by Manuel Casper, which is named PLConfig, but it uses raw sockets, so it's not really portable, and it was only able to configure and query Unplug 1.0 devices. Later we found a Wireshark dissector, and finally there's a package by Divolo, which is half proprietary, half open source, which allows you to only set up network encryption keys on the devices. So you're not able to query all the vendor-specific and standard-specific Ethernet frames. So we wanted to make something which is portable, scriptable, and of course can query any device. So there's already a DIB package. You can change the standard input, output, and error streams. So if you want to give raw comments to a tool, it's possible. You can configure your devices, of course, you can set network encryption keys, and you can query any link statistics specific frames. We also discovered in that proprietary frames, you can dump the SDRAM and the NVRAM of the chips, so possibly coupling this to the 1 minute time frame that you have to get the TE key, you can probably get overkeys and overmode. And there's also something interesting in two senses. First one is the sniffer mode allows you to first see the beacons, which are sent by the stations, just like with Wi-Fi. And you can also configure the destination MAC address of where the sniffer should send for Ethernet frames. So suppose you send this to a broadcast address, since it's sending something like 100 frames per second, it's kind of interesting. We'll make a presentation right now. Okay, so we're starting the tool. I'll query the device, which is get the software. I'm not sure you're seeing things. Is it better? Okay. So first of all, we'll make a get device software request to discover the chips. More, a little bit more. A little bit more? Okay. So, is it okay?
At the back, they want very large font.
Okay, one more.
Okay,
perfect.
Big font are good.
So, as you could see, we detected a device which is an Intel 63K and running this firmware version, and which is not upgradable. Some devices are upgradable. This one is not. So I don't know what I can show you. There are, well, Let's start with a sniffer mode, it's funny. So you can enable, do not change the state, or disable it, so we'll enable it, and it's going pretty fast. So I gotta disable this. No,
Too fast.
okay. Anyway, if we add run Wireshark, you'll see that there's a lot of Ethernet frames being sent by this sniffer mode, and you can get a lot of physical information. Since we could not pair our devices, we won't be able to show you the link statistics informations, but you can get very detailed informations about the tone map being used between two devices, and for each subcarrier you can get the modulation of it, so it can be interesting if you want to do an estimation of the theoretical rate between two devices. So, as I told you previously, we're looking for contributors to test the tool on different devices. So far, we've been trying to get a wide range of devices, but not everything has been tested. It could be interesting to implement a GUI on top of it, because well, it's command line based, so it's interesting, but it's not really it's not night candy. And we have other projects in parallel, such as doing a Wireshark dissector for it. And we will probably start prototyping a PLC stack using a FPGA and a PHY chip, so that we can have an open source device, open hardware device during power line communications. So question session is now open. If you have any question, okay.
Please wait for the microphone. The microphone is coming from the
Gotcha. We have 5 minutes.
You have 10 minutes now for questions.
Okay.
Any question?
Yeah, it's switched off. No, it's on. Okay, have you seen any of these power line devices with included power over Ethernet? Because I always thought it would be a nice feature to have power over Ethernet, because it's generally plugged into a power socket.
No, usually they are using the energy coming from the electrical network.
Yeah, my question was, if you want to attach some, for instance, voice over IP telephone, which is capable for power over Ethernet, so it would be easier because you have just one thing which plugs into your network, featuring one-time network data communication and power for the phone. But it's not yet on the market, or is anybody planning some devices which feature PoE?
If I get the question right, you want to know if there is power over Ethernet devices?
Output by these devices.
Not
that we know of.
No.
There's quite a lot of things to change on the power supply of your equipment if you want to do power line communication natively. So.
Okay. I see. Thank you.
I got a question. For the sniffer mode, do I need the NAC, the network encryption key, to do sniffer mode?
No.
No. What do I see then without the NAC? I just see encrypted packets.
No, you see unencrypted packets.
Unencrypted.
Yes.
Okay.
Actually, you don't see all the frames. From what we have seen, we didn't investigate very much the sniffer mode, but basically it's mostly management frames that we see.
Yeah, everything that is related to the MAC, to the access to the medium, which is in clear, is available to a sniffer mode.
Well, is there any form of integrity checking on frames? So is the injection possible? Or just encryption? I mean, the question is there any form of integrity checking on frames?
There's something I didn't talk about, but there's something called loopback mode, which allows you to send a custom Ethernet frame to a device, and it's going to spread it to the network. Does that answer your question, somehow?
Somehow I was asking about the cryptography. I mean, if there is any form of integrity checking, or it's just plain encryption based on the key, just that.
How the encryption system works?
Yes. If there is any form of integrity checking, I mean, something like a cinch or like that. Is injection possible, I mean, in the network?
You can use devices in a mode to inject frames. You will have, if you want interaction with the other devices, to be able to be part of the network and use the NEC key that we were talking about, so to somehow recreate this NEC. Do we have more questions?
How easy is it to use your code as a library to write, for example, stuff like KDE or GNOME network monitors that show me the link quality and stuff like this? Or is it on a monolithic application?
That's a good question. I think this will require quite a lot of code refactoring, but we already thought the tool to be a library, so it should be fairly easy for you to have high-level primitives such as configure this equipment with this key. So yes.
Thanks.
Have you investigated the use of GNU radio and the universal software radio peripheral for decoding PLC signals?
Of course, when we're talking about using FPGA to implement the MAC layer, this is very close from what GNU Radio is doing. Basically, power line communications is injecting radio into a cable. If you look at it from the physical layer and radio emission, what you're doing, you're taking high frequency modulation and you inject it into a copper cable, which is electrical cable, but for instance, you don't need the 50 Hertz, 220 volt or 110 volt to have communications. You can do it on a normal cable. So from the radio aspect, it's very close from a radio technology. So you can use any kind of advanced radio, MAC layer, like GNU Radio, and use it for the MAC parts. After, you just need the right physical interface with the medium. Do we have more questions?
How much is the maximum distance between two environments, or is it possible to enlarge the distance by your firmware? Or?
Wait for the microphone.
I can repeat the question.
The question was, what's the maximum distance between two equipments, and provided that you change the firmware, is it possible to extend the range?
The power transmission is limited by hardware into the chips so far. We may have different vendors with the IEEE standard coming up, and we may see some that will be able to adjust the power transmission. The limitation now is 100 milliwatts. So you have the same kind of limitation you have in Wi-Fi. The only thing you can play with is by injecting more properly the signal on the electrical cable, like using a coupler, like inductive coupler that you can wrap around the cable, and you will be able to do a magnetic injection of the signal into the cable. Then you will extend the propagation of the signal. In terms of distance, you can go up to 100 to 400 meters of cable between two devices. With quite advanced injector, you can go up to 1 kilometer of cable, but you need to be able to have a clean channel at the physical layer.
Have you looked at other types of protocols for PLC communication? There's one called LoneTalk or LoneWorks, made by a US company called Echelon, which is very, very popular, probably one of the most implemented PLC communications. Have you looked anything at that?
When I was splitting the PLC world into low bitrate, high bitrate, LoneWorks belongs to low bitrates, so the low band that is between 3 kilohertz and 150. We have been only targeting Ethernet technology like HomePlug. HomePlug is developing another competitor to Loanworks called HomePlug CC, which is a little bit inspired by Loanworks. But so far we've not been using Loanworks. People can add functions to faifa for Loanworks or HomePlug CC. Question? Is our English okay for everybody?
Yeah.
It's okay?
So
You know, we a French question.
Let's have a bit of broken English then from another French. The question is, as I understand, it's very hard to basically analyze from a hardware perspective if you don't have an adapter. So the fact is your power line is acting as an antenna. How feasible is it to take it as a tempest kind of eavesdropping equipment with an antenna from a remote distance and physically re-inject that directly into a current in order to just use the PLC normal adapters and faifa to decode these kind of messages?
If I get the question clear, you want to tempest the power line cables?
Yeah, and then re-inject into another clean power line, I would say, that you will plug HP AV, home plug AV, in order to use faifa as it is. So how feasible this would be?
If you tempest the cable, it will damage the signal for sure. Again, if you are not able to be part of the logical network, it will be hard to receive the frames and work with that. You will have to implement the whole
Two-way. Okay.
Well, in practice, you may notice that two logical unplug AV networks, for instance, I get one at home, my neighbor has another one, both are sharing the same bandwidth because it's not capable of, for instance, this one uses the low subcarriers and the other one uses high subcarriers. They're not capable of doing this, so they're interfering with each other.
One question that we have often is, I have power line communication at home with my ISP. Is my neighbor able to sniff my communications? The HomePlug AV standard says that all devices going out on the market are using the same default key, which is nice. So basically everybody buying out-of-the-shelf devices can share everything. I have been doing the test in a 6-story building in Paris. From the 6th floor to the ground floor, I can see the communications. So you can have a large Ethernet hub sharing everything in a building if you don't change the default key. Yes.
So you no longer need FiFunk.
No. You mesh your... Do we have more questions?
More questions?
Are there any outdoor equipments available on the market you can buy, or it's only for dedicated ISPs that want to use this technology to spread internet?
You can find equipment out there. Of course, you switch from a couple of dozens euros to €1,000, but yes, you can find. Actually, the chip and the technology is the same, only the power transmission is different, and the way they inject the signal on the medium voltage or low voltage is different. Last year, Google, this small company, they bought a power line communication company in the US called Current Technology, which is providing internet access to several states in the US, because they wanted to see what is the results of internet access over power line.
Could you please elaborate more on the outdoor use, because you just said you missed the schematics and you didn't say anything about the outdoor use. So how can it be used outdoors?
So when we're talking about outdoor, we are talking about the so-called public electrical network. So depending on the countries, you will have to theoretically interact with the electrical carriers, electrical provider in your country, which will be the medium manager. So different countries have different regulation. In the US, for instance, electrical carriers are now putting themselves into telecommunications carriers over the power line cables. In France, it's more complex. In Germany, they have different parts. Switzerland, for instance, Freiburg, they have a small network there. In Africa, there is Algeria and South Africa implementing that technology for access in different parts. I've heard that in some parts where they have electrical network, they can feed BTS for GSM through power line communications, and they can have one only network on the electrical network. In terms of technology, again, you are finding the same kind of technology. So home plug AV, for instance, is used for outdoor also. It's slightly different because they have been implementing a small MAC layer for managing, because they want to be in master-slave mode. They don't want anybody to be at the same level on the architecture if they are ISP. So the master is at the core of the network, and you have slaves after the meters for each home. IEEE is now doing also a draft for outdoor implementation called IEEE BPL.
It's very, very similar to the DSL architecture, in fact. So you get the physical layer, your physical layer is almost the same because your copper and cables are very similar, but you also have work on having provisioning systems and things like that. So at home you would have, for instance, that kind of router. You put it on the public, on the emitter, and you get Wi-Fi or home plug AV on the home side.
It's supposed to be closed.
Oh, sorry.
Okay.
Any more questions?
Yeah, I have one question. How well does this deal with if you have different phases? For example, you have a family house, you get 380 volts from the power company with 3 phases, and you usually don't care on which room is on which phase, but now with PLC you start to care, so how well does it work?
So usually electrical network in 3 phases mode is 1 neutral cable and 3 phase cables.
Yeah.
Of course, if the 4 cables are very close one to the other, you will have injection of the signal from one cable to the other.
No, but you get 383 phases from the outside, and then you divide it in your house into 220 volts with 1 phase. But it could be that your living room is on a different phase than your bedroom, and you want to have these 2 rooms connected. So will it work or not?
Usually you will have to use the core, the head of the network when you have your blockers and emitter. That's where you have the 3 phase going. After, depends on the electrical network, but if somehow 2 phases are very close one to the other, you will find the signal going from one cable to the other. Another technique is to use the neutral cable, because it's the same for 3 phases. So if you inject the signal on the neutral, you're sure you will find this signal on the 3 phases. And also on electrical network, the neutral is cleaner. It's just because of the way the impedance between phase and neutral is done.
So, and the devices you can buy in the shop, they use the neutral cable or not? I mean, if I buy now three devices that I give to my parents, will it work or not?
Of course, yes. I do not know the house of your parents, but
it's a common house that gets these 3 phases from the outside. So
I will recommend briefly to use the head of the network and use the neutral cable to inject the signal. So to find a plug that is very close from the head of the network and plug the devices there.
okay, thank you.
All right, then. Thank you very much.